Hi, my name is Diagnoses. I'd like to present statistics taken from a table of 211 demographical regions in England that report the amount of men and women admitted to doctors who came out with a diagnosis of obesity. I chose this data set because it falls in line with some personal interests of mine. I am interested in the different peoples around the world, who humanity is, and I am also interested in the topic of health. I've spent a lot of time reading on nutrition, exercise, etc., and my views in the world are influenced by what I have learned about what is healthy. Now, on to the beginning of the presentation. Let's go over what kinds of variables we have since we have those in the agenda. I'll talk about them a little bit and then I'll start showing them and everything, and I'll go through the different elements of everything that I put together. So yes, first we have our categorical variables. There are two, which are the geographical designation and the gender of the people admitted in the span of the year 2014 to 2015 who were diagnosed with obesity in England. Second, we have continuous quantitative variables. The variable this variable here again is the number of people admitted in the span of the years 2014 2015, which is again a 1 year long span who were admitted to the doctor with the diagnosis of obesity. Third, we have possible lurking variables. Look at the massive constant differential between males and females in England. Studies are telling that English males being males produce several times testosterone that women do, which is a stronger fat burner than the primary female hormone estrogen, and because of multiple direct and indirect effects. Testosterone boosts metabolism, boosts competitive behavior, and reduces muscle-wasting secretions, causing increased fat loss in multiple fields. Males in England are also statistically more likely to be physically active, as shown here. Thirdly, males are less likely to see a doctor than females in general. On those three tendencies alone, it becomes fairly explicable why there are not as many men in England who are diagnosed with obesity as women. So yeah, just to give some background real quick, I know I said I'd go into this later and stuff, but I'm just very briefly going to go to this. Overall, if you look at the female rates for obesity, they're higher. You have to consider that BMI also factors into the male obesity rates. And so if your BMI is over a certain number, that means, that can either mean you have a lot of muscle or a lot of fat in the male case because of that hormonal difference, which tends to incline men more towards the muscular. Um, so yeah, that has to be taken into consideration also. But yeah, the male record, if you look at the columns and eyeball it reasonably, it's pretty clean. So yeah. And yeah, this covers region of England for 2014, 2015. I go over the table. I'll discuss things like highlighting and all the other small details there too. So yes, now as to any kinds of associations, having obesity and being of a certain gender have absolutely no link. It's just that being female makes one inclined towards storing body fat, making them more likely to be obese, but that's it. And obesity in men must have its own causes. So basically, women, because their hormonal profile is different, um, they're it, it's a it kind of like it kind of acts like a um gives it that, some extra forward momentum towards obesity because the hormone factor is adding on to their lifestyle. Being humans, they're likely to adopt the culture that's around them after a period of certain time. So there's going to be propensity to eat like men do. So you're going to see women, gaining a bit more weight and finding themselves obese and stuff, um, even though they might not be completely sedentary and stuff. The requirements to be obese for a male are a bit harder than for a female when it comes to obesity. So yeah. Um, so yes, an increase in population size and density are also an association because that increase does not cause a greater density of obesity. Going to the doctor also does not predispose someone to being diagnosed with obesity because of multiple reasons that would necessitate the need for someone to go see one. And the reason why I say that is that a person might come in with the pretense that the doctor might try to stick them with the diagnosis and stuff. This is paranoid thinking, obviously, and not true. If there's nothing wrong with you, doctors are gonna test you and say there's nothing wrong with you and stuff. It's not like a car mechanic and stuff where it's a bit more, it can be more surreptitious. So yeah, it's definitely not the case. So yeah, no association between going to the doctor and being diagnosed with obesity because there's no association with going to the doctor and really being diagnosed with anything. So yeah. Um, Now, the kind of sample we are dealing with here is closer to a cluster sample because of how the different sample groups are not stratified. So yeah, like we're not looking at like we're not trying to represent the population uh, through a like homogeneous strata and stuff. We're taking random samples, so that's called a cluster, like a random cluster sample or a cluster sample. Um, Now, obviously, there's no way to really order these regions because it's just a span of 1 year from the years 2004 to 2015, but it's easy to see the spectrums of shapes the data can take in its default state, so to speak. No, sorry, in its default state, so to speak, the data will take on an appearance of a cone-shaped distribution, and I'll show that real quick. Um, so yeah, so in looking at the table, like I'm saying, you can arrange this all sorts of ways and get all sorts of shapes and stuff, but in its natural state, as you take it from the table, um, it takes a that's written down. But yeah, so in its natural state, it's a plateau distribution, but you can reorder it into something that's like a comb, or something that's skewed to the right or skewed to the left. So for a skewed to the right, you'd have all the quantities clumped more to the left, and for skewed to the left, it'd also be clumped to the right. So yeah, but in this natural state, this is a plateau distribution. So you see sharp peaks and sharp troughs and stuff. Yeah, in the coma type distribution, it's be more like a bimodal comb. So like you group similar heights together, and but but you make it so you'd overlap it with shorter heights, so it'd be like high low high low high low, and then for this graph overall, you might see like an overall incline towards higher ups and higher lows and so on, and it'd become like a bimodal thing. Um, wouldn't be a perfect comb, but it'd be pretty close to a comb, and you arguably call it a comb. So yes, but what's important to understand is that the shape of the distribution only matters when we try to relate variables. Because the categorical variable of the geographical designation is purely associative, we don't try to arrange them because of influence on how much more causally linked variables exist. So yeah, we don't try to reorder this and stuff and try to relate things to between quantity and category because they're purely associative. So if you try to find some R correlation, it's a waste of time because you basically have a linear forecast of something based on the region, and yeah, there's no real association there. The data is not going to give you anything on that. Um, if you look at the population map for England, you see that pretty well. I'm going to pull that up over here. Um, I'm going to switch between 2D to 3D. So yeah, and I'll designate the different regions. So yeah, up until about here is southern England. You have London, lots of heavy population clustering there and stuff because people want to be in the city and there's lots of jobs there and everything and trade, lots of things going on. But over there, there's almost an inverse correlation with obesity and stuff. But when the population goes up, the obesity diagnosis density goes down. It's not very responsive to that population increase at all. And over here we have what's called the Midlands. The Midlands basically start from here, about this line to somewhere up here, and yeah, there's not much there. And in northern England, you also have some peppering too. But where we see who's really leading and what is in the table. Now this is sections from northern England. Like it says over here, northern England starts here. You scroll down, and you have a total of a little over 3,000 diagnoses. And then for the Midlands, you have 3,585. And for southern England, you have just 1,636. So like I said, you have all these people and everything because of London, but there's almost no obesity rates that are being reported. Look at this. You go through all the different regions, and yeah, nothing. Absolutely nothing. And like was kind of shown before, the women have a severely high, uh, much higher obesity rate than men. Yeah. Um, so yeah, so now I'm done with the introductory bit and stuff and externalities. I can go on to, you know, the whole process of this thing, what I went through to make it, and what everything means and whatnot. So yeah, so looking at this table, we explained the table over here. We have green and red cells. The green cells are numbers that lie within the IQR range. Um, as it says over here, our IQR guideline for the lower bound is negative 28.50 by this quick calculation. IQR was 21, so we plug that in. And the lower quartile is, go down here, 3. Upper quartile is 24. We plug and chug all that stuff. And yeah, our upper bound is 55.5. So we use conditional formatting rule. We click this button and just read things and fill them out. It's pretty natural. So yeah, it automatically highlighted this red because I designated that option. You see it. Quite a amount of things breaking the upper limit. Not so many things breaking the lower limit, obviously, because you're not going to have negative people. Going down to our 5-number summary, since that's pretty related. Have it listed under key values because it's important. Our minimum 0, first quartile is 3. We calculated that with this function right here, quartile.ext. Minimum is calculated with this right here. This is takes the minimum from B2 to C212, so that's a rectilinear span from cell B2. X coordinate is B, Y is 2, all the way down to C212. As you can see, the numbers are positively going down. It's not like a Cartesian plane. It's kind of the opposite when it comes to the y-axis. But yeah, so we got that value. Median is taken the median with the same rectilinear span as you can see in this function. The third quartile, the same thing. I have the number 3 over here. It tells me which quartile I want. It's basically the same how I did the first quartile. I did comment 1 after defining my rectilinear spans and fill in the argument that I needed for the quartile. It'll specify the number of the quartile I need. And for the maximum, again, max rectilinear span, they're all fairly similar to each other. Yeah, for sample standard deviation, I did stdev.s for our span of numbers, and then you have the population. That's a different function, same result. Range, I just put that in, subtracted the maximum from the minimum. Didn't use any functions for that. And IQR is 21. And how I calculated that was I subtracted the third quartile. Subtracted the first quartile from the third quartile. And from that, we got this box plot. I generated this in a website. So we have our minimum, our first quartile right here, which is 3. Our medium is just 12. Third quartile, which is 24. And our maximum, 283. And where we got this data was Hospital Episode Statistics, HES. It's a British website. The original table is pretty cluttered, but I managed to pull the data out and make everything work all nice. Got all the regions and everything. It's about 211, 217 items. So yes, this table, so basically what I did was I highlighted all this stuff right here in this table, and I hit insert, and I chose the column chart, and then I mess with the axes, make them line up. What you do is you right click, and then there's an option that says select data. Maybe it's up here. I use the desktop version, not the browser version. Yeah, right, so here's one, select data. And yeah, it'll ask you for your chart data range. Wow, this is taking a while. Okay, anyway, so I guess very briefly I can say I just read off the window and stuff and defined different things until I got the result that I wanted. So yeah, so if you put this in a scatter, this is what it looks like. The line for the women follows negative 0.0399x plus 32.249, with a linear correlation value of 0.066. So yeah, weak. And then R value is 0.073. So yeah, this shows how many confounding variables there are between the region you live in and what the obesity rate is going to be. Um, yeah, so it's just a very weak linear relationship, and also consequently a weak correlation for that reason. There's just too many confounding variables. And to make sure I didn't miss anything. Oh yeah, so we have the correlation between the data sets. You have the data sets. So basically, it takes the male and female columns and correlates them with each other. Correlation is 0.91. So yeah, there's a you could predict the female outcomes based on the male outcomes, and the female outcomes, because there's not so many confounding variables. Yeah. Anything else I could talk about over here before I go over to my next tab? Yes, so right here we have the simplified version. What I showed you is very cluttered, so I'm going to break things down simply. I just put everything in proportions based on the region. So we have the three regions, that's the three dots, and each are at the proportion of the total population of England, and for every proportion of the population they have the how much they have the respective proportions for how many obesity diagnoses they attain. So we have Northern England, which is over here at 27.47%, and that makes up roughly 37.29% on the graph. It's a little bit more vague, but shows up in the table over here, and so on. And we end with a correlation of negative 0.99, repeating almost. That rounds to negative 0.99. So yeah, so we end up with a very long decimal here, and and taking the R value, and taking the R value, it's the same thing, because that's what Coral does over here. It takes the R value from R squared. I didn't want to say there is an absolute correlation and stuff, because you can see the dot comes off the line. So yeah, it just didn't agree. Now, if you look at this table over here, it shows translate those percentages into population numbers. That comes from the English census. And yeah, so those percentages are broken down into the actual amount of people that are in each region, adds up to the total population of England, obviously. And yeah, so for Northern England, we have 3,104 diagnoses. In Midland, and again, remember this is from the year 2014, 2015. And yeah, so in Midland, or the Midlands, we have 3,585 OBC diagnoses. And in Southern England, we have 1,636 diagnoses. And that gives us an R value of those columns of negative 0.99. So yeah, didn't change anything, obviously. So now going over to histogram stuff. If we take the histogram, well, over here I have my outliers and inlier values and stuff. Over here I have my bins and stuff. These define the different ranges that these define like the amount of counts and stuff that you take for certain numbers. So and that shows them the frequency table. So for the frequency, you have 117 items that fall from 0 to 9. That's what the 9 means. Then 64 items that fall from 10 to 19, and so on. And all that's necessary for building the frequency function. You need to define your bins. And it asks you to highlight your bins column. and your intervals are there. So when you go to make your graph, the proper data is pulled because you highlight all that stuff to make the graph. And this is the graph right here. As you can see, it's skewed to the right because all the data clusters to the left. And it says it right here. Now, studying the male pattern, the female pattern. The female pattern tries to smooth itself out a little bit more than the male pattern. Male pattern seems to heavily favor clustering to the right, but the female pattern tries to get a distance away from that. Doesn't really work. Doesn't really achieve that bimodal thing. You look at what's called the 5-number summary for this. Standard deviation is 25.85. 469, minimum of 0, first quartile is 0. And of course, we're doing all these with the VBA functions, so yeah, we have that real floating point precision going, and that robotic accuracy. And so the median is 1, the third quartile is 14, our maximum is 117, and that is illustrated in our box plot over here, 0, 1, 14, 117. Want to look at correlations in R values and stuff. We have this table over here with our R squared values. R squared over here for the orange, the females, would be the root of 0.5888, which would be 0.767333, and then some, so roughly 0.77. And then R squared for the males comes out to 0.6260990,337. And yeah, so what does this mean? Well, I guess because of the skewing tendency, things are more forecastable, and that's why you get a stronger linear relationship. Both of these are skewed to the right, so because they follow like the rigid form in a pattern, you can forecast them, and then you get of course you get a stronger linear relationship. Now you might wonder, like, why is the value so low? Well, that's because linear function doesn't completely encapsulate everything here. You could do a polynomial analysis and stuff, and it'll give you a kind of R squared equation where it'll model the curve very nicely. And you could also do, I believe, a logarithmic modeling too. That might even give you some more closeness. Depends on how close the dots are to the line and everything. So yeah. Over here, I took the 2 columns again. I pasted the values so I can get a correlation from them. This is the male column, as you can see, and W over here is the female column, and they correlate to 0.94. So you can like before, you can estimate the female outcome with the male outcome with a certain degree of confidence. It's important to note that this is very different than what I did over here. Over here, I was taking the self-correlation for females and males, but over here I was taking the intercorrelation between male and females, and that's why you have 0.94 here and those other values over here. If you want to square that 0.94 for transparency, what you come out with is 0.8836. So yeah, much tighter correlation there because blue and orange follow each other more closely. So yeah, when you take that line of best fit, it just kind of like cuts through there, and yeah, it's a bit it cuts through much closer to the dots. So yeah. Now for some concluding words, I did learn quite a bit from this project. I was made more aware of the situation in the UK when it comes to health. I read that with there's more sedentary stuff being doing at work, and people are more sedentary, and it's bringing down their health, and they're buffing the sugar and fats in foods, and now while obviously this newspaper was wrong about fats, fats actually for a significant portion of the population helps hormone balance, which actually combats fat production, because when you consume fat, your body stops producing it. This is something people in the fitness industry have known since like the 60s or 70s. And so yeah, so the part about the fats is wrong, but sugars is definitely correct. When you bring up your glycemic index with artificial sugars or simple sugars, it really hurts the body. But things like fructose are a bit harder to get yourself fat with and whatnot. Um, I also learned that, you know, even though London has a better has a has a better socioeconomic sphere, doesn't exactly lead to people, um, you know, being lazy and not wanting to work and all that stuff. Obviously, people find ways to exert themselves and don't feel too gorged on what they have. And the close proximity doesn't seem to limit people's desire to want to get out and stuff. That doesn't seem to scare people, despite this generation dominated by social media and stuff. And I'll just show London in 3D. So yeah, that was a little counterintuitive. And that was interesting. And to recap, you know, there's lots of interesting things that can be found from correlations, and things can be displayed pretty nicely and concisely with things like box plots. And five number summaries are very good at taking this large amount of data, 211 points, you know, and putting them into, allowing them to be put into the headspace to be thought about. Because otherwise, you're just scrolling through numbers and you can't get a grasp of things really. I mean, there's so many names, and there's you know, two columns. It's yeah, you have 211 regions, but you have two columns, so it's ultimately 422 items. So yeah, that becomes a lot to think about. And yeah, I'm really glad that to whoever's watching this, I'm really glad you took the time out to listen to my presentation, and and I hope you liked it. Have a great day.